text kindly text in the chat section that you cannot hear me, and then I'll try and see if I can move. I have Vodafone here, and then I have Telecel here, and then I have MTN here, just to make sure that um, today I'm not disappointed. So please let me know, okay? But also try and check from your end if your network is good, okay? If your network is good, and you should. Okay, thank you very much, Jonathan, for confirming that. That's good. Okay, so today we will continue with the basic stuff we were learning last week. Today, what we'll do is that we'll blend in the programming. I assume that by today, most of you have the software needed, and you have things set up, and we are prepared to go. So I will be writing some code, just doing basic stuff. So please don't panic. Don't panic. What I want you to do is to follow along. Then in your spare time, you do that. I'll leave some try or test things for you to do on your own. And then you, of course, do the assessment on Monday. Okay. So today we will have a lot of things to talk about, but thankfully we have um, done most of this in our preceding course. Oh, let me do some corrections here. Okay. So thankfully, we have done most of this in our preceding course, and you would not need to really struggle to understand the foundations of what we are going to talk about. So today we'll talk about variables, we'll talk about identifiers, the names of variables, of course, identifiers. We'll talk about constants, creating them in C++. We'll talk about data types, most of the types we use basically. We'll talk about operators, we'll do some examples, all the others. In fact, we'll do arithmetic, relational, logical, assignment operators, we'll do all of them. And then we'll talk about how to collect input from the user using cin, and if you want to collect a whole line and stuff like that. Then we'll talk about, of course, string data type, okay? I think I should change that. Okay, so string data type, okay? Then we'll talk about how to change or convert from one type to another. We call that in programming type casting or type conversion, okay? So let's proceed very quickly. When we talk about variables, I believe most of you for now know very well what a variable is, right? A variable is a container for storing a value during the program execution. Now, what you can do as a programmer is to, or when you program, is to change the value of the variable during execution. In fact, during execution, you can change the value of the variable, right? So a container you need to hold values must have a name. And we discussed in our previous course that variable names in programming are called identifiers. We use them to identify the variable. So there's not much of, in terms of rules per se, but some small nitty-gritty things you need to know, okay? What you need to know is that variable names in C++ can start or can contain any set of letters. When I say letters, I mean uppercase or lowercase letters. So you can have letters from A to Z, anything from A to Z, capital, of course, anything from A to Z, lowercase. Remember, in most programming languages, the programming language is case sensitive, especially C++. So because it is case sensitive, you must specify that you are writing a particular programming language. Okay? So you must specify that you're writing a particular variable name. Okay, so when you write lowercase a, for example, you write A, small letters, it's different from A, capital letters. Okay, A, small letters, A, capital letters. Yes, to us, they are the same thing, but to the computer, they are two different things. I will demonstrate to you very soon, very shortly. Then you can also use digits. Digits here, I mean numbers. So any combination of numbers between 0 and 9. So 9,999, 9,999,999. They are all just 99999. Okay? So please take note of that. You can use any combination of numbers. You can also use the underscore in C++. You can also use the underscore. Okay, so the underscore is the character you get when you press the shift key and you hold the hyphen or the minus button. Okay, when you hold the hyphen or the minus key, you get the underscore. Okay, so those ones are there. But the only catch is that you can use any of these, but you must begin the name with a letter or an underscore. Okay, you cannot start the name with the number. Every other thing is illegal. Every other thing is illegal. Okay, so please take note of that. So you can start the name of any variable in C++ with any letter of the English alphabet, lowercase or uppercase, then any number and using underscore. All other things, including what? Question mark, full stop, hyphen, apostrophe, the ampersand sign, the caret sign, the at sign, the hash sign, the star sign, all those things. You cannot use them when you are naming variables or when you are creating a name for a variable, which we call identifier. Okay, and if you remember from our previous lessons, we learned that you can for creativity, you can use a mixture of different kinds of naming conventions. Okay, we have something we call camel case. Camel case is where you start with a lowercase letter or lowercase word, and then you simply in the middle of the word somewhere or the second word you put a capital letter. Okay, so for example, you can see username. It's an example. You see, you start with lowercase, and then all of a sudden you increase capital, and then you come down. So you see, the camel has like a back that is a hunchback of some sort. Okay. Then another example is max value. Okay, so you can see the hunch where you have lowercase letters and then you have the capital in the middle somewhere, just to help you differentiate that these are two words that have been put together into one word, because we have said that the rules for naming things in C++ are that, or is that, you cannot use any other character apart from letters, numbers, and underscore. So space is illegal. Space cannot be put in the middle or inside the name of a variable. Oh, Mr. Boateng, um, Mr. Boateng, please check your network, okay, or check your connection, okay, Mr. Boateng. Yeah, please check your connection. I'm sure your connection is the problem. Most people are hearing me very clearly. Okay, I'll proceed. Then you can also, for purposes of creativity and doing or writing names that are made from compound letters, or sorry, compound words, use what we call Pascal case. In Pascal case, you start with a capital letter, then you have small letters, then the second word will have capital letter, then small letters. Then if there's another one, capital letter, small letters, capital letter. So we normally have this when we are writing names of classes. Okay, so names of classes. So user profile, something like that, or get data, something like that. You see that? Then you can also use what we call snake case. This is where you put the underscore. Okay, so in snake case, you use letters and then underscore, then letters and then underscore, then letters and then underscore, and letters and underscore, that kind of thing. Okay. Then you can also use all caps. We call it screaming case. Okay, so screaming case, we have screaming snake case as well. Okay, so here we have screaming case, and then we've mixed it with snake case. So we have screaming snake case, where we have one word underscore, second word underscore, second word, and then you keep going. Okay, then this is not. Hold up. Okay, I just took this without looking at it. Well, let me remove this from. Yeah. So this is not so these are the ones that you can use in C++. Okay. Now let's demonstrate. Since we are doing C++, let's go back. Remember, I said that you can run C++ from your browser. Okay. So let me find the browser. Okay. So I have, sorry. Oh, oh, oops. Okay. So I will run C++ from the browser for this demo, and then I'll show you something. Okay. Okay. So I'm running it from programize.com. Okay. So last time, I think I have the link up for you all to see, so you can have a look at, and then you can also run it from the browser as well. So I'll put a link in the chat also, so that those of you who forgot or who didn't join us early last time will also see it. Okay. Then I said that, so this is a C++ file. Okay. In fact, if we run this right now, it will print start small, ship something. Okay. Something like that. Okay. Now, I want to just use this to demonstrate naming of variables, just to show you something. Okay. So let me just remove this. And then remember, last time we talked about using namespace as a way to prevent us from having to type that scope resolution all the time. Okay. So if you remember that this is the bare or raw C++. Okay, this is what your file should always look like when you are starting. When you are starting to program in C++, you should always have line 1, line 2, line 2, line 3. Line 1 is just a comment. Okay, you can remove it. There's nothing wrong. There's nothing important about it. Okay, so you can have line 1, line 2, line 4, all the way to line 7. Okay, this is your raw C++. Now, let me just demonstrate the creation of a variable just for us to see. So we can have maybe, for example, int amount. Okay, so this is legal. Okay, but a moment I do 2026 amount. Okay, note that. Let me just show you something. If I run this, nothing, of course, happens. Okay, so it means that everything is working correctly. But if I remove this and then I try to create a variable name with a number starting, notice that I have an error. And the error is that they are expecting inside the main method, right? Inside the int main method, which this one is, okay, they've seen that on line 6, you have a number starting the variable name. And that's what they are telling you, that you have error. Do you see that? Everybody sees that. So you should not start the name of a variable with a number. Neither should you start it with any illegal character. So let me start with another character and show you. So the compiler here, the compiler will let you know that you are wrong. Do we understand what I'm explaining, please? You see, it's very simple. Is it understandable, please?
Yes, sir.
If you start the name with a letter, you are okay. If you start the name with an underscore, you're also okay because underscore is also legal. Okay. But if you start the name with how do you call it? If you start the name with any other thing which is not legal, okay, for example, if I start the name with comma, notice that it is that one, the one with the comma, that will return the error. You see, the one with the comma is the one that will return the error. It's not the one with the how do you call it? It's not the one with the underscore or the one without the underscore. Okay, so take note of that. Okay, okay, good, good, good. You are following me very well. That's good. Let's go back to the slide and then we will continue. Okay, now how do we declare a variable or create a variable? So to create a variable, we need to specify the data type or the type of the variable, okay? The type we already explained in our previous class. You already know what a type means, okay? The type simply tells us whether it's an integer, a floating point, a double, a boolean, a string, etc., etc. Okay? Then we need the identifier or what we call the variable name, what we just discussed. So you need a type and then you need the variable name. And then sometimes when we create the variable, we want to put something inside the variable. I told you variable is just like a container. It contains something. So if you want to put something inside, you use the assignment operator, which is the equal to sign. In programming, like I said before, the equal to sign is the assignment operator. Everybody remembers that. Then, of course, you put the value. So the value is there. The value is what you want to assign to the variable. So let's see some examples. Okay. So what you can do is what I did initially. You can create the variable and put something inside. So for example, here we created a variable called my number. The data type is what? Integer or int. Okay, so int my number is equal to 12. That's what you are seeing up here. So you've created a variable or a container called my number. In this container, you can only put whole numbers. Okay, and then what you have done is that you have put the number 12. Remember to always add or put semicolon at the end of the line. Okay, so here we are now doing programming proper. So you cannot do it without the semicolon. C++, every line must end with semicolon. The same thing you've done in one line, you can also do it in 2 lines. How do you do it? You can create the variable somewhere in the program. Then afterwards, you can now, sometime in the future, you can now put something into the variable. So let's just say inside your int main method, you create the variable on the first line. Then maybe somewhere in the program, you decide that, okay, then I want to put 21 into the container or into the variable. So you can do it in one of 2 ways. Create a variable and put something inside there and then in the beginning, or create the variable in the beginning, then later put something inside the variable. Remember, you cannot put something inside a variable you have not created. Okay, let's demonstrate. Let's go to the programming. Please remember, we are doing programming, so we'll be going to the programming a lot. Okay, so try as much as possible to get the tools I have asked for installed. Okay. Oh. Um, can we see my browser? Hello?
No, sir.
You can see my browser, right?
Yes, sir.
Okay. Or we should use the. I learned most of you are on Windows and you have code blocks, right?
Yes, sir.
So I'm trying to blend all of the tools just so that everybody who's using anything can. Some of you also have your phones, and because you have phones, you'll be using your browser, the tool on your phone. That's why I'm trying to do this for some number of times. Then I'll switch to another one so that everybody sees how things work in all. But they basically work the same all throughout. Okay. I'll switch very soon so that at least those of you who use other tools too can see. But it's the same thing, okay? It's the same thing. Okay, so yeah, so we want to test or we want to run this thing, okay, empty, and let me show you, okay. Mr. Darlington, is there a problem?
Negative, sir. Service, I just joined the class, sir.
I cannot hear you.
Service, I'm saying negative, sir. I just joined the class, sir.
You just did what?
I just joined the class, sir.
Ah, okay.
Yes,
I
sir.
can see your index number and your name, but I don't know what the reason for that is. So don't worry. Okay. So
Yes, sir.
let's go. So let's create a variable. So remember, we need a type. So let's just create a simple data type like integer. Let's call this amount. And then we can set it equal to maybe 16. Okay. Now, in the future, remember we talked about printing out. So we can print out amount. Okay. And then, so when we print out, we should see 16 appearing on the console. You can try it yourself. It's very, very easy. Okay. Now, if, for example, I try to just create a variable amount and I don't put anything inside, but I try to run or print something, okay, so fairly reasonable. Okay, let's see if it will work for character. Okay, character, it did not really work. I don't know what that character is, but it's showing over there. Let's see if it will work for Boolean. Okay. Okay, 0, false. Okay, let's see if it will work for string. Okay. So we're just trying out just so that, okay, but I don't think it will work the same for the, okay. Okay, so the thing is that don't try to create a variable. Not put anything inside and try to use it. You should not be doing that. That's very, very dangerous. Okay, try and yeah, Madam Lois or Louis, Sir Louis. Sir Louis, we are on a time, so please talk. Hello? Okay, he's gone. Okay. So don't try and use a variable without putting something into the variable. That's what I'm trying to demonstrate to you. Okay. So for example, and then another thing is that don't try to use a variable before you create it. Okay, so here you see line 8, we are using the variable. Before on line 10, we create the variable. But the right process would have been to create or declare the variable before using it. So I think most of us, we are familiar with this kind of thing. Okay, you cannot do this. You see the error. Okay, so you get errors if you try to do something like that. Okay, so I'm just trying to help us to understand, appreciate that this one is programming and things will work a little differently than when they worked in or on the paper or in the book. Okay, so that's that. Then variables in C++, you can create them. For example, here we created, I'm fond of creating a variable called amount, so please forgive me, okay? Now here, we created a variable called amount. The type is what? Float. And what it does is that we put the number 1.5 into the variable called amount, okay? Maybe on line 1. Then maybe on line 2, we ask the computer to change that value to what? 1.7. Okay? Then on line 3, we ask the computer to change that value still to what? 21.02. So now when we print the value or when we print the variable amount, what will we see? Will we see 1.5? Will we see 1.7? Or will we see 21.02? Which one do you think we'll see? Pardon? Hey, today I'm not hearing anything from you.
So you see the 21.02.
Is he answering the question? Hello?
The 21.02.
21.
Yes. Thank you very
02.
much. Thank you very much. Thank you. I think Joseph is just chatting somewhere. Okay. So 21.02 is what you see, because every time you assign a value, a new value to the same variable, the value will change. Are we okay? So 1.7 will change whatever was inside amount from 1.5 to 1.7. Then the moment you do 21.02, it will now change the 1.7 to 21.02. Okay. For float, you must add the F to the end. Okay. So it's just a small something you must do in C++. I think in Java as well. Okay, and in C as well. Okay. Now, remember we can do output, right? C out will do output. Last week, I think I spoke about it. So I just put it here just to remind us, those of you who have forgotten and who didn't go back to the slide or go to the book or whatever it is. C out is still for printing something to the screen. Okay. Okay, so you can also combine whatever you are printing with text. Okay, so for example, if I'm printing numbers, a number 35, and the 35 is inside the variable age, and I want to print I am 35 years old, or I am 29 years old, or I am 18 years old. What I need to do is to do the C out, less than, print the beginning of the text, and where I want the number, when I get there, I use the less than, okay, so that this variable can be placed in the middle of the text. Oh, who is chatting? Hello, who are those people? Richard, be careful, okay? So as I was explaining earlier, so you put the variable, if you want to print the value of a variable, you need to put it in between some less than when you have a print statement, okay? So cout usually prints strings, okay, or only numbers. But if you want to mix the types, you must use the less than in the middle so that you can put whatever you want to print in the middle. Are we okay? So an example over here is what you see. I have a variable called name, I have a variable called age, and I have a variable called balance. Okay. Now I want to print John is 27 years old, and John's balance is maybe 625 cedis, 620 cedis, 50 pesos. Okay. So if I want to do that, then I'll simply have to use the cout. Then where I want the variable to print the name, I put the name in between the less than quotes, okay? Then I print the text I want to print. I put the text I want to print, right? So John is, the is should be in quotes with spaces around it, okay? Then I have the age of John, okay? Then have the years old and maybe the balance that John has, okay? I put that also in quotes, and then I put the less than. Remember, you only put the less than at the end if you want to do more things at the end, okay? Let's demonstrate on the programming or in the programming. This time, I think we should use Visual Studio Code, okay? Okay, so everybody can see my Visual Studio Code environment, right? Can we see my environment?
Yes,
Yes,
sir.
sir.
Okay, so
Yes,
those of
sir.
you who have the browser or Visual Studio Code or code blocks or Dev C++ or whatever it is, I'm just trying to use different ones so that at least everybody will get a hang of it. But this is basically what I use on my laptop because I cannot install some of the Windows software. Okay, so here I think you just I want to put our thing into our project into folders so that I can send them to you. Okay, I'll share them on the what do you call it, on the LMS for you. Okay. So code, let me just call it code, okay, for now. And then let's go into code. So I think in code blocks, you simply click on project, and then I'll show you how to do that also on code blocks. It's very easy to do that on code blocks. Okay. Then here you just press this one, this plus file. This is for file, this is for new folder. Okay. So, and then you just give it a name. So I just want to call it example1.cpp. Okay. So C++ files, they have the extension .cpp. Okay. So once you hit enter, we have created the C++ file. It's very easy. Okay. In order to run this, I've already told you that you need some extensions. Okay. Last time I think I showed you that you need some extensions. I'll put some videos to that help you know what to install. Okay. So I run most of my stuff from here. I have a lot of things in here, which are extensions. Okay. But it's basically very easy to run this stuff. Okay. So remember, we need the hash include. Let me increase this so we can all see. Then IO stream. Okay. Then we're using namespace std, then int main. Okay. Okay. So hello. You have a question?
Sir, please, the spelling for the IO stream.
Yeah. Noted. Okay, so we are demonstrating variables being used. Remember we said that. So let's create a variable. Let me call this name, and then let's call this Kwame. Okay. Then let's create a variable called age. Maybe Kwame is maybe about 19 years. Okay. Then let's create another string. Let's call this nationality. Okay. And then Kwame is Ghanaian. Okay. So now let's do a small print statement that prints out Kwame, then the person's name, and then sorry. Okay. So let's do a small print statement that prints the person's name, and then the person's age and the person's nationality. Okay. So let me wipe this out. So let's do code. So your name is, then all you need to do is to do the name over here, then do the, okay. So that's what you need initially. Okay, let me reject this. Okay. Sorry about that. I have autocomplete. So Copilot. So Copilot is trying to complete our code for us. But basically, you can see that you write the cout. Okay. Then you write the less than. Okay. Then you follow it with what? The text you want to appear before the variable, the content of the variable. So I want to say your name is Kwame. So you have to write your name is space in quotes. Then where you want the Kwame to appear, you put the less than over here. I want to put a new line at the end. That's why, remember last time I spoke about the end line, okay? So the end line can do that trick for you, okay? I hope everybody understands this one. I think last week we were practicing something like this, okay? How to print and then end line and all those things. So if you want to see the outcome of this, you can just quickly right-click anywhere inside and then run the code. Once you run the code, you will see that the issue has been, the code will compile first. Remember, C++ is a compiled programming language. It takes a while to compile. Then once it compiles, it will produce the results you want. So it has finished compiling. You can see the results. Your name is Kwame. Do you see that? Because I'm saying your name is, then you see space. So you can see space. If I remove the space from here, you will notice that the space will also disappear when I'm printing. Okay. So after it has compiled, oh, I removed what? What did I remove? Oh, I think I removed the entire thing. Sorry. Okay, so if I remove space from here, sorry, notice that it will compile. Okay, and you see that your name is Kwame is against the S and the Kwame are together because I removed the space from here. Do we see that? Do you understand that? So if you remove spaces, if you want to have spaces in your writing, you should put spaces in the printing. Else, if you don't put spaces in the printing, there will be no spaces in the writing. Do you see that? Hello, do we understand that?
Yes, sir.
Okay, so I'm putting the space back, and I'm doing the next one. See out. So I want to print Kwame is, okay. Then the age of Kwame. Then I'll put space years old. Okay. Let me reduce the size of this a bit so that it can fit on the screen. Okay. Okay. Then let's do end line. Okay. So next thing I want to print is Kwame is 19 years old. Okay. So where I want the Kwame to appear, I can put the variable, which is a container, and then I can put the text inside quotes and in between the less than signs. And I can put where I want the age to appear. I can put that over there. The reason why we use variables is that in the future, if the name is no longer Kwame, but the name is, let's say Abdul Rahman, if I run this code, it will compile, and then you will now see your name is Abdul Rahman. Abdul Rahman is 19 years old. Do you see that? Very convenient. Okay. Variable is a placeholder. If you are no longer called Abdul Rahman, but you are called John, then all you need to do, and then maybe your age is no longer 19, but your age is maybe 24. All you need to do is to change that, save that, and then rerun that. Once you rerun that, notice that now it will compile again, and now you see that same information. Hello. Same text, but we have just changed the information so that it's saying that your name is John. John is 24 years old. Is it understood, please? The demo we are doing with the printing. Yes. So the variable acts as a placeholder, the container. It contains something we can change during the execution or during the running of the program. All we need to do is that if we use a variable, it's easier because all we need to do is to come here and change it. Once we change it, the entire thing will change wherever it sees that container. Okay. Let's go back to the slide. I think there's no even need to do the, okay, so but I can still do the Ghanaian, okay? So we can do name, can do name, container, okay? Is, oh, sorry, quotes, space is less than, Then we can do nationality. Okay. So once we save that and we run that, notice that to recompile, remember compilation takes some time, okay? So your name is John. John is 24 years old. John is a Ghanaian citizen, okay? If John was not a Ghanaian citizen and John was maybe an English, all we need to do is to change the text over here, save the file. When we run it, you see that John will no longer be a Ghanaian citizen, but when it is printed, John will now be an English citizen. You see that? For someone from England, okay? And then this Ghanaian. All we did was to change what is here. Okay? So you should be doing variables where you want things to change for user. Okay? Any questions? I hope it's understood.
Yes, sir. Yes, sir. Understood.
Okay, thank you very much for the feedback. Okay. So let's proceed very quickly. Now, going forward, you can also declare more than one variable at a time if they are the same type, okay? So for example, over here, we have 3 integers. You can create them one by one. You can say int x equal 5, semicolon. Int y equal 6, semicolon. Int z equal 50, semicolon. So those are 3 different lines, okay, for 3 different variables. But because they are all int, you can also write them as what? Int x equal 5, comma, y equals 6, comma, and z equal 50, semicolon. Semicolon is put at the end to indicate that that's the end of the integer declaration, initialization. So you see that if they are all the same, there's no need to create them one by one like that, okay, on 3 separate lines, but you can just put them all together on one line, okay? Remember, the rule is that they must all be the same type. You cannot say int x equal 5, comma, f name equal Kwame. No, Kwame and 5 are not the same int. So you cannot do that. But if they are all integers, you can just declare them together. So we see the example with a string. The comma is used to separate the next one and the next one and the next one. Okay. You see the example with the float and then the example with the Boolean. We'll talk about data types very soon. Okay. I hope it is understandable. Okay. Then sometimes there are some variables we don't want anyone to change their value. Oh, who's that?
Yes.
Let me find the person and mute the person. Come on. Okay, I think he's muted now. Okay, sorry about that, okay? Now, there are some times you don't want anyone to change the value of the variable. Okay, so for example, something like pi. Okay, notice that pi is something we use often. Okay, when you're calculating circles, something involving circles, spheres, maybe a cone or something, you use the value of pi or radii. Okay, now if you don't want people to change their value, or maybe if you are a business person and you are building a software for business and you don't want anyone to change the rate for a loan, okay, what you would do is that you want to create something called a constant. A constant is a variable. It's also a variable, but this variable, nobody can change the value during the running of the program. Okay, so we told you variables, you can change the value. Variables, that's their main thing. The name variable means it changes. Okay, but as soon as you put constant or the word const in front of the variable declaration, what it tells the computer is that you don't want anyone to change the value of the variable. Now, if anyone tries to change the value of the variable during the running of the program, they will get an error. Okay? So I have an example here to demonstrate. This example, we have a variable called myVal. MyVal contains the number 15, but MyVal is special because MyVal has the const in front of the name. So what it means is that this variable, once I set the value, nobody can change it, or nobody should change it. If you try to do that, you get an error. Let's go and demonstrate in the programming, okay? So let's go to Visual Studio Code. Okay, I hope we can all see my Visual Studio Code. Let me do another example. Okay. What's this one? Remove this. Okay. Let's do example 2.cpp. Then let's close the sign. Okay. Okay. So we have a template file. Okay. So let's create a constant variable. Okay. I think let's make it a double. Okay. Because we know pi is very big. Okay. Now, if we try to print it, okay, if we try to print it, we will see the value of pi being the number. Remember, let's explain what is happening over here. So we simply had the file, the C++. You need all of this to run the C++, okay? So on line 4, we created a variable called pi, Pi, which is equal to what? 3.14159, okay? And that's what we set pi to, okay? Then on line 6, I just put the spaces in here just to make it easy to read what this one is doing and what this one is doing, okay? So on line 6, I'm just printing the value of pi, okay? So remember, we've already explained what this one is already, okay? So this one is a print statement where we have a number being printed as part of the string, okay? So if we run this, okay, we will get the answer down here, or the value that you are getting down here. So can you look down here? Okay, everybody looking down here, you can see the value of pi is, then colon, then you have 3.14159. Okay, now if I try to change the value of pi, okay, let's say somebody has come up with a new value of pi, and that value was 3.14. Maybe let me do something like, let's say that somebody has come with a new value of pi, which is 4.999. Okay. Now, okay, so you can see my thing is trying to tell me this line will cause a compilation error because pi is declared as const. Okay. So the Copilot is trying to explain that I'm going to get an error, but I'm just going to be stubborn, and then I'm going to ignore Copilot, and then I'm going to still run this all the same to see, so that you can see for yourself what the results of these things are. So you see for yourself that when you try to change the value of a constant, okay, this is a constant. when you try to change the value of a constant, you are getting an error, okay? And the error is that you cannot assign a variable pi with constant qualifier type to another value, okay? Once you declare a variable constant, you cannot reassign the variable, okay? So this one is unacceptable. So const is used when you want to declare a variable as a constant and that nobody should be able to change the value of the variable. Are we okay? Today I'm taking my time and we are slowing down. We are slowing down so everybody can understand. So please try and understand and follow us, okay? Okay. Then, of course, you've already seen me talk about or use data types, okay? So we have in programming, no data types specify the kind of operation and the kind of data you can put inside the container, which is the variable, okay? Now, in programming or in C++, there are three main kinds of types. We have simple data types, which we all know. We have what we call structured data type. We'll not talk about it for now. And we have pointers. So for now, we will talk about simple data types. Now, there are three main categories of these simple data types. We have integral, we have floating point, and then we have enumeration, okay? Integral is the basic types we know, like int, like int, like character, like bool, those things, okay? Then floating point is for decimal numbers. Then when we want to create our own data types, we use a specifier or we use a type we call enum. Okay, enum is the enumeration type. For now, we will not talk about enum. Okay, we'll leave it for later. And then I'll delve deep into the integral and then the floating point data types, which we are now. The data type, the one we all know about is the int. Okay, the int data type. Type is a very simple data type. Okay, int, depending on whether you mix it up with something called the modifier, you can be looking at what 8 bytes to 16 bytes to about 32 bytes. Okay, so int is can be very big if you need it to be. Okay, you can modify the int data type with some few modifiers. We call them modifiers. We have the signed. Signed means that when the type can include positive and negative numbers. Okay, unsigned means that the type can include only positive numbers. Okay, so you can put it in the beginning. You can see something, some types written or some variables in C++. You see signed int or unsigned int. Signed int means that you can have positive and negative. Unsigned means that you can only have positives, 0 and all the positives, no negatives. Okay. Then sometimes you will see short and long. Short is to indicate that we want to have, or we want you to create, how do you call it? We want to create variable which is an integer, but we want to make effective or optimize use of space. Okay, so that one we call it short. Okay, so short data type. And then we can have long. Long means that we want to create a type that has very long, an int data type that has very much space. Okay, so we can see some of them. You see long int, or you just see long. Long means that it's just an int. Okay, then short means that it's a whole number, but it's a very small whole number. Okay, so that one. So the space or the amount of space is what basically differentiates the short and the long. The short is 16, while the long is 32 bits, okay, or 4 bytes. Okay, 16 means there's 2 bytes. Okay, so please take note of that. But you can also see long, or you can see short. Unsigned short. signed short, unsigned long, and then signed long. Okay, so please take note of that. In addition, the integral types can be Boolean. Okay, for Boolean, you see bool, where we are also only saving the data in 1 byte. 1 byte means we have 8 bits in there. So either true or false, 0 or 1. In memory, they are saved as integers. So that's why we call them, we group them under integral data types. Okay. Then character data type is also similar. All the characters on your keyboard are part of this group of all the characters on your keyboard are part. You store them by using quotes, okay, by putting them in quotes, right? Character includes the numbers as well. So the numbers, special characters, the letters, uppercase and lowercase, right? These can all be represented using ASCII codes as well, okay? Then if you need more memory to store an integer, maybe a very large integer, which cannot be stored in long, you can get 64 bits. 64 bits is 4 bytes, okay? So that one you use long. If the number is very big and you need at least 64 bits to store the number. Are we okay with the integer data types? Sorry, the integral data types.
Yes, sir.
Okay, so I think we mostly understand what an integer is, a whole number. Then if you have a decimal number, you can also store them in C++. We use what we call the floating point type. So in C++, there are 2 of them. We have the single precision we call float, and then we have the double precision we call double. And then in C++, we have another one we call, if you want a very big double, we call it long double. Okay, so long double is very big, right? Very, very big. Okay. So here I have some examples to show us. So the int, we have my num, we can put 1000. Okay, int, we have x, we can put 90. Character, we create them, we write in the character the CHR over there, then we write the grade or the name of the variable, and then we put the variable's value into quotes, single quotes, and then of course you end with semicolon. Same applies to what my car, and here we are putting the question mark sign into the container. And we have float. Float is for decimals, right? Some people prefer to leave the F out, but it's advisable for safety to put the F over there just for safety, okay? Then double, you don't need to put anything or any F. I think I forgot to put that, okay? So double, you don't need to put any F over there. You can simply store a double in memory like that. You can also use scientific notation. So this is equivalent to writing 1.2 times 10 to the power 16. Okay, in programming, we can't do the raised to the power just like that. So you need the E to represent the raised to the power. Okay, very important. Then Boolean, you simply store it with what? The BOOL keyword to indicate that it's a Boolean. Then you have the variable's name and then the value of the variable in both cases. Okay, I think most of us are familiar with that. You can also collect user input in programming or in C++ using the function called cin. Okay, so before you cin, you need to create a variable for storing the value you are going to collect. You must store the value you are going to collect inside a variable. So that's why you must do the variable declaration. Okay, so let's go and practice this one and then come back and then check what we understand by it. So if we go, let's go to the code. Okay, can everybody see my editor, please?
Yes, sir.
Okay, so if we, let me clear this one out. Okay, so if we see the example, let me create another file and then let's show an example. So example 3.cpp. Okay, so example 3.cpp, here we are just going to do something very simple. So include IO string, okay, using namespace, and then int name with the return to 0. Okay, so you always need to have this one. Please always remember, if you forget everything at all, don't forget to have this one before you start programming. Okay, so let's create a variable where we can collect someone's name, but this time around, instead of putting the name directly inside the variable, instead of putting the name directly inside the variable, we will collect the name. We will collect the name from the user. Okay. So here, what we need to do is to do a small, what we call a prompt. Remember, I explained what a prompt is. A prompt is a statement that tells the user what to do. Okay. So we want to enter. So we want the user to please enter your name. Okay. Then when the user, let me reject this. So when the user enters your name, what do we want to do with the name? We want to allow the user to see in the name, okay? Or let's do something simple, okay? Let's do something simple first. Age, okay? Enter your age, okay? And then, okay. So now, remember, you should always create the variable before you use it. So please remember, if you want to collect something from the user, create a container that has the correct type that you want to collect, okay? So you want to collect a whole number, then create a container with an integer. Okay? Here, just so that we can learn something, I'm going to use the word short. Okay, so remember I talked about short and long and int, okay? I'm going to use the word short. And then since age cannot be negative, so I'm going to use unsigned, okay? So you can see, okay. So unsigned short age, okay? Then if we want to see the outcome, we can do you are age, okay? Yeah, oh, okay. End line, okay? So very simple program. It does something very simple. It allows you to enter your age, then it collects the age, then it prints the age with the text. You are maybe something years old, okay? So if we save it, you have to run it. So when you remember, compilation takes a while, so you should always wait for it to finish compiling. Then can you see that it is asking us for the text? So we give it a number, maybe 13, and it says you are 13 years old, exactly as I have written over here. So you can do something like this, okay? Are we okay?
Yeah.
Mr. Michael,
Yes, sir.
what's the problem?
Sir, please, why is it that the C in you use greater than and not less than?
Why is that what?
The C in you used greater than and not less than.
Well, because that's what we use. For C in, you use greater than. For C out, you use less than. That's what we use. That's the rule. So you follow the rule. Are you okay?
Yes, sir. Yes, sir. Sir, can you use write a code to print the name?
Yes. I said I was doing something simple for you for now. Okay. Hello?
Yes,
Mr.
sir.
Michael?
Yes, sir. Yes, sir.
Something simple for now. I didn't say
Okay.
this is all you can do. I said something simple for now.
Okay.
I'm going to talk about strings very soon. Name is a string, so I want to reserve that one for later. talk about how to collect a string also. So
Oh,
just bear
okay.
with me for now. Okay.
Okay, sir.
Okay. Yeah, I think we are good. We are set. Okay. So you can do something like this, very simple. Collect. Please, you don't have to use short and sign. No, I just want to put it there so you can know that it is also correct. Okay. You can simply use int. It is also there. Okay. Okay. It will still work the same way. Okay, I just want to let you know that you can use any of this. We are just giving you all the knowledge, and then you decide which one you want to apply. Okay, so don't think that it's only unsigned short you can use, and please, I also don't want you to also think that it is only int you can use. Okay, I've taught you that now you can use unsigned, you can use signed, you can use long, you can use int, you can use long. So you decide on what you want to do. Okay. Sorry. So you are at liberty to decide on the data type and then choose the type you want to do, okay? And let's do another one with the balance, okay? Let's create a variable, which is a double, and then let's call it balance, okay? Or bal. Then let's do a small cout asking you to enter your balance. Okay. Then once we ask you, we need to now collect it. So remember, greater than. Remember, the cout goes with less than, and cin goes with what? Greater than. Please don't mix up the two. Very important. Okay. So we want to write you are maybe 20 years old and 20 years old and have, or let's just move this to the next page. Okay. Let's move to the next page. So yes, see how, so it will be easier to read. Okay. Okay. Then we'll just leave space and your balance. Sorry, balance is well, Ghana cedis. I don't think the sign is there. Okay. So let me just do that with the balance. Okay. Balance. Okay. And then do the end line over there. So everybody can follow me nicely. You can put a full stop there if you want to. I think I should do the other one so that people don't think it's the other way you can go about it. Okay. So here, remember last week we talked about the new line character. Okay. So, or the escape sequence. Okay. So now you see you can do more than one at a time. So I'll collect your age and then I'll collect your balance. So we enter we enter a fake age and we enter a fake balance. We collect two of them. Okay, so if I save that and I run that, so to ask you for your age, if I enter that my age is maybe 92 and my balance is maybe 1200. Okay, so see that you are 92 years and your balance is 1200. Okay, let me just, I think I should just copy this stuff. I will have the stuff, or I'll have the code in a folder somewhere for you. Okay, so on the LMS, I'll try and see if we can put that on the LMS for you. So don't worry. Okay, but for now, let me just be posting the code in the meeting. Those of you who don't type quickly, so you can just copy it and paste it in your browser. When you paste it in the browser, it will work. Okay, let me show you. Let's go to the browser, the code editor in the browser. Let's go there. Okay. Okay. So if I paste it in the browser, okay, and then I run it, it still works in the browser. Okay, so you can run it in the browser. It will work perfectly. Okay. So you can see that. Are we okay?
Yes, sir.
Yeah. So you don't have any reason to say that I cannot run C++. I don't have a computer. I don't have anything. You have a phone. You can run it on your phone. All you need to do is to go to the text editor in the browser and then paste the code in there, click on run, and it will run. So you can learn C++ even with your phone. Okay. Now, there's another thing too I want to show you. You can actually do this thing. You can actually collect more than one input at a time. Okay. So let's say I don't want to say enter your age, but I want to say enter your age and balance. Okay. So you can do enter your age and balance. Okay. Then if you want to do that, then all you need to do is to remove this one. Okay. So you can collect more than one at a time. Okay. This is how you do it. If you want to collect more than one at a time, you do cout, then you print the prompt you want to print. Then under it, you do cin greater than. You do the first one you want to collect, and then greater than the second one you want to collect. So if I run it, see something. Okay. So enter your age and balance. So maybe your name, your age is 12, and then your balance is maybe 12-year-old, you have just 200 Ghana cedis. You just put space, and then when you hit enter, notice that 12 and 200 Ghana cedis have been put in the correct places. Please remember, you must, when you do something like this, when the user is entering, they must use space to separate the two things. Okay. If you do this, however, and the user enters maybe 34, sorry. Okay, the user enters maybe 34 and hits enter without entering the second one. Okay. Okay, so it picks it even with space, it picks the two things. Okay. So you can see that it picks the two things even with space. Okay. So please, the enter key, even with the enter key, it picks the two things. So please take note of that. I hope it's understandable. You can enter or you can collect more than one input at a time.
Yes, sir.
Okay. So we are on track, right? Everybody understands what is going on. We can practice.
So, sir, what if the user inputs only one digit? Let's say only the age without the balance.
So let's try. You can also try it. So only the age, maybe 67. And that's what just sits there, or
Yeah, enter.
enter. Okay.
Yeah.
Nothing happens until you enter the next one.
Oh, okay.
If you hit enter again, nothing happens. Nothing happens until you enter the next one. So it will never work until you enter the next one.
Okay.
Okay.
Thank you.
Okay. So you've seen it for yourself. In programming, if you have any questions, you can program it and try and see it for yourself. All right. It's something you in Ghana we call it fili gadochi. Whatever you think is possible, program it and see for yourself whether it is possible or not. You can see it for yourself. So let's go to the next one. Okay. So now everybody understands user input now, right? How to collect input from the user. You can collect Boolean, you can collect how do you call it? Character and so on. Okay. I'll talk about the string very soon. Okay. Okay. Now let's talk about arithmetic. Okay. So programming languages are like a big calculator. Okay. We can use them for calculations of all sorts. Now we use operators as special characters to initiate calculations. Okay. So everybody knows about addition, we have subtraction, we have multiplication, everybody knows division. There's something called the modulus. There is the increment and the decrement. Maybe that's the one most of us are unfamiliar with, but I think in our previous course, we talked about increment and decrement operators. Okay. So in programming, we have these operators. We call these ones arithmetic operators. they are useful for the things you see them do. Okay, so I think I have some examples over here. So if x is 10 and y is 3, then if I do x plus y, it's just 13 because 10 plus 3 is 13. If I do x minus y, is 7 because 10 minus 3 is 7. If I do x star y, it is 30 because 10 times 3 is 30. If I do x divided by or backslash y, it is 3. The reason it is 3 is that in programming, I think I explained to you before, but let me still mention it. In programming, if you divide 2 integers, you get an integer. If you add 2 integers, you must get an integer. Programming languages, especially C++, is very strict about data types. That's why we teach you data types, okay? So you must understand that if you have 2 integers, even if you are expecting a fraction, you will not get a fraction. You will rather get an integer, okay? There's a way to force the computer to give you a fraction. There's a way to do it. I'll show you very soon, okay? Then everybody remembers modulus. Modulus is when you do a remainder, okay? So 10 modulus 3, when you keep subtracting 3 from 10, the last number is what? 1, okay? Or you divide 10 by 3, it will go in 3 times, the remainder is what? 1. So that's the answer, remainder 1, okay? Then I have some example over here to demonstrate the plus and the minus. Plus and minus simply is for adding 1 or subtracting 1. So for example, if I have 5 and I do plus 5, I'll get 6. If I have 5 and I do minus 5, I'll get I should get 4, right? Okay. Is there a question? Yeah, Filigaducci. Okay. There's no question. Okay. Sorry, I wanted to copy this thing and send to your chat. Okay. So for those who were not quick at typing, okay. Now, so if, for example, I do 10 divided by 3 and I get 3, but I want to get 3.5 like 3.3333 like the correct answer is, then I must make sure that one or both of the numbers are decimals, okay, are floating point numbers. So if I rather declare A as 10.0 and I declare B as 3.0, then when I do the division, I will not get 3. Instead, I'll get 3.3333333. Okay, that kind of thing. So we have integer division because when you divide 2 integers, you get an integer, and then we have decimal division. So please take note of the difference. Okay. Then we have operators for because we can have mixed expressions, we have operator precedence, which helps the computer to know which one to do first. So we have multiplication, we have division, we have exponentiation, we have modulus, we have addition, subtraction, and then parentheses. When you see them in any expression mixed in any way or the other, this is how we evaluate them from from start to finish. Okay, we evaluate all the parentheses first from left to right. So if there are more than one parenthesis, we start from the one on the left, and then we go to the next one on the left, all the way to the last one on the right. Then we go to multiplication, we go to modulus, and we go to division. These ones, they have equal precedence. So the one we do first is the one that appears first from the left. Okay? So if you see multiplication first from the left, we do multiplication first. But if you see modulus first from the left, we do modulus first. And also, if you see division first from the left, we do division first. So please take note of that. It's from left to right. Then when you see addition and subtraction, we do them after we have done with any of the other ones, okay? So addition and subtraction, we do them also from left to right. They have equal order of precedence. And so when they have equal order, what it means is that we do the addition first if it appears first from the left, or we do the subtraction first if it appears first from the left. So please remember, you should always do the brackets first. You should always do the multiplication, the modulus, or the division next.
Sir.
Then you should always do the addition or subtraction next. Then when you are done with that, you do the assignment. You put the answer, if there's equal to, you put the answer inside the left, the thing appearing on the left. Are we okay? So I have an example just for us to demonstrate with. So in this example, look at this carefully. This example, we have a mixed expression. We have brackets, okay? We have brackets. We have addition. We have division. Okay, there's addition here too. We have subtraction. We have multiplication. And then we have addition. So looking at the rule, PEMDAS, okay? Parenthesis, exponentiation, okay? Modulus or multiplication or division, and then addition and subtraction. Remember, left to right. So if we look at it, which one do we do first? We do this one first, okay? Sorry, okay? We do the parenthesis first, okay? So the parenthesis should be done first. Then when we do the parenthesis, remember you go inside. So you go and do the addition that is inside the parenthesis. Okay, so you add 1 to 3. Okay, which results you get 4. So the answer from here is 4. Then if you look at all the expressions, now you have addition, you have multiplication, you have subtraction, you have division, you have addition. When you look at them from left to right, the one that has highest precedence is the multiplication. So you multiply 2 by 3, you get 6. Okay? So then from now that you've multiplied them, you've removed this one from over here. So this one has been removed. Remember, this one has been removed. So now you have 6 over here. Remember, here you have 4 over here. Okay? So the next one, which has highest precedence, because you have addition and division and addition, you do the division. So division will be done next. This will be number 4. Okay. So you divide 4 by 2. The answer will be 2. Okay. So that's the one you see over here. So now you have 5 plus 6 minus 2 plus 4. Okay. Please remember that. Then from left to right, the addition, this addition will be done next. So this is the 5th one. So it's 5 plus 6. So you add 5 plus 6, you get 11. So this will be done. You get 11. Then it's 11 minus 2 plus 4. So minus from the left, minus is next. Okay. So you do 11 minus 2, you get 9. So you've now subtracted this. So you now have 9 plus 4. Okay. So please take note of that. So 9 plus 4, you add them, you get 13. So the answer to this one is 13. But you see, the assignment operator should be the last thing that is done. So you now put the answer 13 inside the variable or the container called results. So 13 will be put inside the variable or the container called results. Are we okay?
Yes, sir. Sir, please, I have a question.
Oh, okay. Ask your question.
Can you use the board mass formula for this kind of thing?
Oh, yes. It's similar to board mass, just that remember we have modulus. Board mass doesn't have modulus. So how do you deal with modulus?
The modulus, that's the percentage sign.
Yes. Board mass doesn't have modulus. How do you deal with modulus?
Okay.
It's the same thing, but just that we have modulus. So board mass is for small children because we don't teach them remainder mathematics. So at your level, you are not a small child. You are matured. You are at the university. So we shouldn't still be using board mass, even though it's the same principle. Understand?
Okay.
Yes. So at the university, at your level, you are more matured than the kids. So we should teach you the truth. The truth is that we have modulus, we have exponentiation, we have other things. Right? We are going to learn more. There's logical operators, there's relational operators. So please remember that all of those things are there. Yes, I know you guys are stuck with board mass, but you have to grow beyond that one too. Okay?
Thank you, sir.
No problem. So now we are making you aware that when you have logical operations, when you have arithmetic operations and they are mixed up in an expression, you are using something similar to board mass, but remember that we have operator precedence where multiplication, modulus, and division have the same priority, but you do the one that appears first from left to right. Okay? So please remember that one. Then another thing you will see or encounter in C++ programming are the assignment operators, the operators that do assignments. Okay, they're very simple. So remember the assignment operator equal to. What it does is that it takes the thing from the left and puts it into the right. Okay, so very simple. So if the left contains 2, it's the same thing that we put into the right. So the right will also contain 2. Now you can also do shorthand assignment. So if you see something like A plus equal B, we've done this before in our previous class, just that we have to still explain it so that you are aware of it, okay? So it works here in C++. If you see A plus equal B, it means A equal A plus B, okay? If you see A minus equal B, it means A equal A minus B. It means there's A on both sides of the equal to sign. If you see A star equal B, it means A equal A star B. Okay, it means A is on both sides of the equal to sign. If you see A backslash equal B, it means A equal A backslash B. Okay, then finally, if you see A modulus equal B, it means we have A equal A modulus B. Okay, it means we are finding the modulus of A and B. Okay, so please remember that. There are a lot more, okay, but we've not talked about them because I don't want to confuse us so much. Okay, I want us to take it one by one. Okay, so let's see some examples. So let's see some examples over here. We have out A, we'll get 2, and we print C out B, we'll get 7. Okay, now if we do the shorthand, okay, if we do A plus equal B, what will happen? We'll get, the shorthand will mean that we have what? A equal, right? A equal what? A plus B. Okay, so it will be what? 2 plus 7, which will be 9. So the new value for A will be 9. Okay, so when we print this one, you should rather see what? 9 over here. Everybody understands that, right? Okay. Then we can also have x equal 10. If we do x plus equal 5, what it will mean is that we have x equal, okay, x plus 5. That's basically what it means. Okay, that's what this one means. Plus equal means we have x on both sides. So it will mean 10 plus 5, which is 15. The new value will now be put inside x. So x will now contain 15 if we try to print x. If we do x star equal 2, is the same as doing x equal x star 2. So x times 2, or 15 times 2, we get 30. So x is now 30. You see how simple it is, right? Because you have the foundation, you see how easy it is, you are understanding these things. That's why we all need to do a foundational course. Very, very important, right? Then the comparison operators. Comparison operators are used to compare whether two or more things are the same. Okay, so they return true or false. Okay, they are very easy. So we have the equivalent operator, which checks whether two things are the same. So for example, 12 equal 18. Because 12 is not equal to 18, the answer that it will return will be what? False. Okay? Or not equal to. It will check whether two things are not the same. If they are not the same, it will return true. If they are the same, it will return false. So for example, 17 not equal to 21 will return true because 17 is not the same as 21. Okay? Then greater than is used when we want to check whether the first thing is bigger than the second thing. So for example, 19 greater than 10, you get true because 19 is more than 10. Then greater than or equal to check whether two things are either greater than or are equal to. So 15 is greater than or equal to 15 is true because 15 is not greater than 15, but 15 is equal to 15. So one of the two things is true, so both are true. Okay? Then less than, we'll check whether the first thing is smaller than the second thing. So over here, 89 is less than 23 is false because 89 is not smaller than 23. Okay? Then less than or equal to, check whether it is either less than or it is equal to. So here, 76 is less than or equal to 192 is true because 76 is smaller than 192. Are we okay? So that's that over there. So we have some examples to show us. So we have A equal to 3 and then B equal to 5. So if we do A equal B, we should get false because 3 is not equal to 5. Okay. Then if we do A not equal to B, we should get true because 3 is not the same as 5. Okay. Then if we do A is greater than B, we should get false because 3 is not smaller than what? It's not bigger than 5. If we do A is less than B, we should get true because 3 is less than 5. Then if we do A is less than or equal to B, we should get what? False because 3 is not less than or equal to B. And if we do A is less than or equal to B, we should get true because 3 is less than 5. So less than or equal to is true. I hope everybody understands these ones. They are very simple and very convenient. I think we've talked about them extensively, so we don't have many issues with them. Okay, very quickly, the last but not the least I'll talk about are the operators, the logical operators. We've seen this before, right? We know how ampersand or the logical end works. So the thing is only true if both of them are true, or if both of the numbers. In programming, we call the numbers operands. Okay, so if both operands are true, then it is what? True. Logical or, it's only true, so it's true if either of the operands or either of the numbers are true. Then the not is what? Is when it is true, we are not will negate it. So the negative of true is false. The negative of false is what? True. So let's see some examples over here. So here, A is 5 and B is 8. So if we do 5 greater than 3 and B greater than 5. So here, 5 greater than 3 will be what? Will be true. And then B greater than 5 will also be true. So true and true, because it's true when both of them are true, is what? True. Okay. Then if we say 5 greater than 3, it's still true. But if we say B less than 5, this is false. So when either one of them or both of them are false, then the answer is what? It's false. Okay. Then we can see the operationalization for the or. This one is true because both of them are true. Then this one is true. Sorry, it's false because this is what? This is false. Okay. 5 is not less than 3. And then this is also false. So false and false or false is false. Okay. Please take note of that. Then for the not, if we find out 5 is less than 3, 5 less than 3, A less than 3, A contains 5, so 5 less than 3 is false, and the not of false is what? Is true. Then 5 greater than 3 is true, the not of true is what? Is false. Okay, so you can also look up these ones too. They are very simple to evaluate. Okay. I'll run a little quickly so we can cover up more ground before time. So if you see the 3 of them being used in an expression, how do you determine which one to do first? So if you see the 3 of them being used, you do the end first. So you do the not first before you apply the end, and then you apply the or. So for example, in this expression you see over here, you ask yourself, is there any not? No. Is there any end? Yes, there's an end. So you come and do the end first. So this one will be true. Okay. Then this one will be true as well. So true and true, the answer will be what? Will be true. So now you are checking whether this one is true or false. So this one is what now? False. So you are finding out whether false or true. The answer is what? True. So that's how come the answer is true over here. Okay, so you can have more than one in an expression. Then you take your time and use this rule to try and evaluate them. Are we good? Are we okay?
Yes, sir.
Okay. I hope I'm not going too fast. Okay. But
Yes,
I should
sir.
not also go too slow. Okay?
I still have a question.
I'm trying not to go too fast and too slow. Okay, Hakim, you have a question?
Yeah, sir.
Please make it
when
quick. Our time is almost up.
yes, sir. Sorry. When I did mention of the board mass, it was an acronym that we use so that we solve the question. What was the PEMMDAS also an acronym that we can use?
Yes. Oh, it's an acronym for parentheses. Parentheses same as brackets.
All right. Thank
It's
you.
another name for brackets. Okay, we call the thing you call brackets, we call parentheses. The name is actually parentheses. That's why I'm saying that when you were kids, we allowed that one because you're just small children. But now you are grown up, so we need to teach you the right thing. So you teach the right thing.
Thank you, sir.
No problem. You're welcome. Okay, so now let's talk about strings. This is the last thing. Okay, I know I'm overloading your head, but this is the last thing we'll talk about. Okay, so strings is a data type which consists of a collection of characters. I think we all know about this from our class before. Okay, from our class, the programming principles class. The structured programming design class. Now, strings allow you to hold more than one character at a time. Character only stores one character. But what if you want to store someone's name? You want to ask someone's name and store it. You see, that's why I paused the string and then I brought it to here. So if you want to create a string, all you need to do is to write the word string, S-T-R-I-N-G, as the data type. Then you create a variable for the string. Okay, so here in this example, we declared a variable called str, okay, or string. And then we have a prompt, enter a string. Then we have the cin, okay. Because string consists of more than one character, you can't just use cin, okay. So you have to use a function we call get line, okay. There's a whole other way of doing this, but I don't want you to even focus on that one. Focus on this one because it's much more easier and there's not bound to be so many errors, okay? So get line will be the function we use, and then inside the brackets or parentheses, you put cin, comma, and then you put the name of the string variable. So here the name is called str, so you put str inside the brackets, okay? So this one will allow you to collect the name on the entire line, okay? Everything, even if it's a sentence, it will collect everything. So long as you don't press enter, it will keep collecting, okay? So I'll demonstrate it to you very shortly, okay? So let's go back again. Sometimes on some of your computers, in fact, to be safe, we want you to use the import or the include statement. So use include at the very top of the string or of the program, okay? just after IOStream, you add this one to the declaration. Then you create the variable by declaring it like this. Okay, you can declare a variable. Means when you declare it like this, it means that there's nothing inside. Okay, but you can also declare the variable and put something inside. Okay, and then you can also declare the variable and then enter something from the keyboard using the get line. Okay, so please take note of that. Okay, before I do operations, let's demonstrate that one very quickly, and then so that everybody gets that. Okay. Okay, so let's get rid of all of these guys. So like I said, if you want to do strings, you must include strings. Okay, string, sorry. So add this one if you want to do strings or use strings. Okay. Some of the programming environments, if you don't add that one, it still works perfectly well. So please, it may work. It will work perfectly well if you don't. Okay. So let's do enter your name. Okay. So now I can do this one without fear or without problems. And then you do get line. Okay. Then inside you do cin and then the name of the variable. Okay. Then if you want to see the results, you have to, of course, print out. So you do your name is, okay, the variable name, and then end line. Okay. Okay. So let's test this one out. I'll just copy the whole thing and then paste it in the chat so that those of you who are slow at typing can type with this one. Okay. I hope it's helpful. Okay. So when you run this, it will ask you for your name. Maybe your name is C, and then you hit that one, and then you see that your name is Kwesi. So you see it works well. Okay. Let me show you. When we use getLine, you can even type more than one. So you can type Kwesi Arthur. Okay. And then when you hit enter, you see it picks up the whole thing, Kwesi Arthur. Okay. So you don't have to care about spaces and the rest. The only problem is when you press enter key. Okay. When you press the enter key, it stops collecting input. Okay. So please take note of that. I hope everybody understands the get line. It's very easy. It's a function that allows you to collect input from the keyboard. Okay. And the input you collect with get line is the entire line. Okay. It says get line. So to collect the entire line of code. Everybody understands this? I hope everybody understands this, right?
Yes, sir.
Yes, sir.
Oh, that's good. That's good. My boys are very sharp and the ladies are so fast. Now you can do some operations. I think we spoke about concatenation. Concatenation is when you attach a string to the back of another string. So in C++, you can do concatenation. So here, look at the example I have. I have a variable called name. I have another variable called last underscore name. If I create a third variable called full underscore name, which is equal to name, and then I concatenate it with last name, what I will get is name space last name, or Luis space Perez. Okay, so I'll get that. So you can use this to do plenty things. You can think of several things you can do. Okay, or you can even use the shorthand plus equal to. So if you have greeting and you want to attach maybe hello world, you have hello, you want to attach hello world to it, or sorry, you want to attach world to it, you can do greeting plus equal quote comma world, so that hello will be attached to or will be concatenated with world. We call this concatenation. Okay. Very, very simple. Okay. Then, who is doing that? Who? Okay. Then another thing we can also do is to access a particular character. Okay, we are going to come back to this one very soon when we do arrays. Okay, but I just want to show you that you can do other things. Okay, so you can access a character using the square brackets. Okay, so, and then you inside the square brackets you place the character or the index of the character. We call the positions index. So the first position always starts from 0, and then we go to 1, we go to 2, we go to 3, we go to 4, we go to 5. Remember, space is a character. So 6, we have 7, we have 8, we have 9, we have 10, we have 11, and the full stop is also a character. We have 12. So here we have 12 characters. If I want to see the first character, all I need to do is to type the name of the string and then give you the position of the string or of the character I want to see. Okay, the position will be inside the square brackets. So please take note of that. Okay. Then you can also use the at operator. The at is a function. So here it uses the brackets, and then you specify the index of the position. You can take your time and experiment with these ones. Because of time, I'll just explain the rest and then we can close shortly, okay? Then you can also change whatever is inside a particular position by using the equal to or using the at operator with equal to. So this is how to change. So for example, if I have capital H and I want to change it to lowercase h, there's no need to delete the thing and then now retype the thing. No, instead you can do the square bracket with the position I want to change. So the first thing I want to change is this character at position 0. I want to change from capital H to lowercase h. So all I need to do is to just put that position 0, make it equal to some quote h, and that one will change the capital H to lowercase h. Are we good? And same applies to when you want to find the length of a string. So you can use the length function to find the length of a string, to return the length of a string. Here, there's a small, I'll come and talk about these ones later on, but you can use this size underscore t to represent the type for a value which contains size, okay? So we'll come and explain this one later on. But you can also use int to do that, okay? So I prefer you use int to do that, which will return that number, okay? The number of characters in this variable. The variable, of course, contains 13 characters, okay? Including spaces and the full stop and the comma sign, okay? So remember to return 13. Then we can also compare strings by using the equal to. So we'll come and talk about this one later on. All of you are familiar with control structures and if statements and the rest. So we'll come and see how we can check whether the user inputs the same as whatever is there or whatever we are looking for, maybe a password or something. So we'll come and see how we can use the equal to check, and then how we can also use a function called compare to check. Okay, so please take note of that. Then finally, if you have one type and you want to change it to another type, we can do what we call type conversion. Okay, type conversion, explicit type conversion. If the programming language does it itself, we call it implicit type conversion. Sometimes you don't want to do that because it's not desirable. Okay, it can result in some very horrible errors. So explicit type conversion is much more preferred because it is much more convenient to do explicit type conversion. How do you do it? You use a function called static underscore cast. And then inside the less than greater than sign, you put the data type. And then inside the brackets, you put the expression you want to convert to a different type. In fact, it can only convert this static underscore cast can only convert simple data types. So let's see some examples. So an example here is that if you want to convert this decimal number or this floating point number into integer, you write static underscore cast, then inside the less than greater than, you put the int, the data type of what you want to convert it into, and then yes, when are you going to upload your slides? Oh, the slides are there. Oh, are they not there? On what you are using to teach us? Oh, okay. I'll talk to maybe I'm sure you are from the degree. I'm sure you are from the degree section. I'll talk to Mr. The facilitator, okay? Please, I'll talk to the facilitator, okay? Please calm down. Okay, so this one converts the decimal 3.3 into an integer, okay? 3.3 into integer, so 3. Then if you want to convert maybe the whole number 25 into 25.0, you can use static underscore cast and then convert it using this double. You can convert using floats. You can convert using Boolean and so on and so forth. So this is how to use static underscore cast function to convert from one type to another. What I want you to pay particular attention is this 2. Okay, so this 2 almost the same, but produces 2 different results. So here, static underscore cast, we are converting 15 divided by 2. What will happen is that 15 will be, because 15 is an integer and 2 is an integer, we will perform integer division first. Get 7, and then now convert the 7 into a decimal. So you get 7.0. But the actual answer, if you want to get the actual answer, you must convert one or both of the numbers into a decimal. So here in the second instance, I converted 15 into 15.0 before dividing it by 2. If you have a floating point number and a decimal and an integer number divided, the answer will be a floating point. So now here you get 7.5. So please take note of the way the compiler or C++ deals with numbers and the like. Okay, I'll end over here. I'll not go any further. I think we don't even have room for questions. I'm sorry. There was a lot to treat today, so please forgive me. Next week we'll have room for questions. Oh, you are going for another class, Mr. Richmond. Please make it fast.
Okay, sir.
Please make it fast. Make it fast.
Yes, sir. Good morning. Yes, please. I want to find out. You see, when we're taking us through the simple data types,
the what?
I'm asking that the simple data type that you have taken us through.
Yes.
Yes. Assuming I want to create a variable where I want to store a number with a text. Let's say position first, second, 7th, 8th. Which of the
that's a string, but that's a string.
Okay. Thank you, sir.
The word first, right?
Yes, sir.
Yes,
so
please remember that it is only
not
the
letter, not the spelling first, but let's say 2 with the ST, or let's say 7 with the
on. It is only us human beings who know that 2 with the ST means 1 with the ST means first. To the computer, it doesn't have context. Remember, the computers are not human beings. They don't have how do you call it? They can't reason. Do you know that computers cannot reason? Hello?
So, yeah, I understand, sir. So as you
computers cannot reason. So if you type 1 with the ST, basically because there's S and T, and S and T are letters, you should create that thing as a string.
As a string first. Okay.
Yes.
Sir,
yes. It's not a number, and the computer will not have any context as to whether it means first or whatever. The computer only sees the compiler only sees that thing as a string. That's all. You are the one who has. You are the only one who has context about what it means. The computer doesn't have context about what it means. Programming cannot do that kind of thing. Okay?
Okay, sir. So I get you. Thank you.
You're welcome. Okay, so please, I would not want to keep the next class from going on. So please, thank you very much. Thank you. See you guys next week. Please post your questions in the forum so I can respond to them.
All right, sir.
Oh, the slides are available. Oh, come on, Mr. Michael. The slides are in your LMS. Please, the slides are there. Though you have not perhaps opened the LMS. You cannot see the slides. The slides are there, okay? Thank you.
No.
Pato. Diploma course rep.
Yes, sir.
Kindly contact your data structure and your system analysis and design lecturer. We want to talk to you.
Okay, sir.
Call him immediately.
Yes, sir.